So let's go for SUSE QE Tools Workshop today. Hi everyone. Today the topic will be to talk about mainly this ticket, which is a follow-up to some incident we had, and we wanted to identify what went wrong, what could be improved, what did we learn from that story. Basically, the ticket, the original ticket is 99246, and the title of that ticket was Published QCOW, which appeared to be uncompressed. So thanks to Martin Duscher, who found that issue, we could see that there was regression introduced, which impacted the performance of OpenQA instances, where it has been observed was OpenQA SUSE QE, because the impact was a performance regression, not big enough so that is actually really significant, like catastrophe happening. Then of course we would have realized that much sooner and much more easily. But it was a bit more subtle, but still some portion of tests were impacted badly, affecting multiple teams, multiple of you. Maybe you don't even know yet that you had been impacted by that, and you blamed, like, I don't know, random network issues. So what we had is showing you some monitoring graph. Okay, so this is panel from Grafana. Should have prepared to load that in before. I know that I opened the others, but this which should show you that the disk I/O times were in July of this year were actually lower than in August. So over the course of August, it was becoming worse, but not worse enough that, you know, we would immediately see that as an alert. So let's see if this will come up. Looks better now. Yeah. So what you can see here are the disk I/O times in seconds. This is kind of like the maximum delay for read or write requests for this one storage device that we use to store the assets in OpenQA. So assets are, to remind, are the ones that come with the test, like the initial ISO files, maybe QCOW files for appliances or in other formats for appliances. But they are also, assets are also used for the intermediate QCOW files. For example, if we store assets in tests and we publish them, then they are copied back from workers to the central WebUI instance. And what you can see is that, well, basically up to this point here, everything was on a lower level, and then suddenly there were, not immediately, but, you know, depending on when tests had been running, longer read times, sometimes even quite significantly. And what doesn't show up here anymore, it's like in Grafana, after some time we don't have the information anymore when we had alerts, but we did have alerts at this time about disk I/O times. As you can see shortly afterwards, without doing anything, we are back below in valleys. So the alerts in turn, they didn't stay alerting. So they alerted and then they went to a state which is called okay again. And then people say like, okay, if it's okay again, it can't be that severe. For example, compared to a host is down, you get an alert, and then afterwards it's okay because somehow the host recovered. Could be that it automatically rebooted, maybe there was a power outage. That resolves itself, right? Similar for if we are about to run into space limits. We have many components that do some kind of automatic removal or some kind of cleanup. So there can be cases where we hit an alert threshold, but we're not staying over the alert threshold, and then the alert turns to okay again without anyone doing an explicit action, without anyone identifying if there's any underlying cause. And that happened again here as well, that we did act on the alerts, and we said like, maybe same as in the past, maybe this is just, what we need to accept. Maybe this is just more tests. Maybe this is just an unfortunate time, and we have just really many tests at a time. And we could see that there was a longer queue of tests. And some people have confirmed that, yeah, there are some tests which are, coming in and maybe clogging up the schedule. So maybe you just need to wait and everything resolves itself, right? If you take a look over the longer time, then you can see that actually it's like, the mean value of read and write I/O times are actually above the average what we had in before. I mean, significantly, you can see all this jitter. I mean, it's not clearly always above a certain limit because, of course, there are idle times. But much more is going on in before, right? So now in hindsight, yeah, we can see that over the course of 1 month, there was really some more significant issue. And then after Martin Duscher could identify that we had a problem with a patch, which I will show you shortly, we could deploy a fix within 2 hours, so very quick. So then the issue was resolved. And this also shows here. So if we take a look here, you can see when the fix was deployed, right? So you see I/O times, and then it becomes better again. And now we are again in this period where we say, yeah, okay, maybe there was a small spike. We also know why that was, and maybe there's a small spike here, but overall the level is much lower again, right? Why is the level much lower again? I mean, what's the effect? What can the effects be of any fix? Who would like to make a guess? Anyone would like to make a guess? Is someone who knows explicitly what the fix was? Yeah. So who knows what the fix was? Okay, so let me show you again let me show you then the patch which introduced the problem. So there was this patch which was called Fix Disabling of Compression QCOW. And it's funny, I should have been suspicious at the time. All the time when a commit starts with fix, I should be very cautious because my experience tells me a fix is likely introducing some other completely weird bug. So yeah, be wary of that. Now there was a previous commit which didn't take into account the perimeter to disable compression. So what this commit was doing is a fix in OS order_inst. And you can see that one additional perimeter is included here. And this additional perimeter is passed here. And then here, you see again this perimeter taken. And then what is changed is reading the variable uncompressed QCOW is replaced by that simple function, that simple variable which we take from the outside, uncompressed QCOW. Well, and then Same as in before. If compress, then we put the -c parameter on QEMU convert command, meaning that whenever we run QEMU-based tests, we compress the QCOW image. Yeah, and then you can see where that variable was moved. So basically, it looks good. It looks nice. It looks like it's doing something, and there had been unit tests. So there had been additions to the tests where we would see that, the command line is correctly generated, and then afterwards we see that depending on this parameter, we see that the command line is generated with the right parameter, and that the -c is there when it should be there when compress has been selected. So to me, I was approving that pull request. To me, that looked good, right? But what happened? What happened is that, well, one place was overlooked where the parameter was not correctly passed. So it was correctly passed when we generate the command line, but then again on a higher level where we would pass it, it was not done correctly, and hence the unit test looks fine. But then if we would call like a real life example OpenQA test, that would not have the C flag, meaning that whenever you create a QCOW image, it would not be compressed. It would still work. It could still be passed around. It could be copied back to OpenQA. Other tests could use it just fine. But everything was 8 times bigger, and it was taking 8 times longer. And this is why it's putting 8 times more stress on the disk to read and write the stuff. So what did this cause? Well, it caused a delay in test execution. It caused weird questions, which I also, did not immediately could link to the same topic, like, could it be that uploading takes longer? Yes, that was the case. We observed that. We didn't know why. Could it be that it takes longer to start tests? Yes, for the same reason. It could be that tests failed or ran into timeout or had other weird problems because it was taking so much longer that the system was pressed out of the parameters for which it was designed. So yeah, after the fix was deployed, you can see that disk I/O times was going down again because, well, now the QCOW images are compressed again and it's better. Now, any additional observations, notes, or questions by you at this point? Yeah, Chris, go.
Yeah, so one thing I found in hindsight, so the first time I was looking at the change, I had pretty much the same observation as you. It looked pretty sensible, and test coverage looks pretty good. But one thing I realized after the fact is this doesn't really try and execute any of those commands, right? So it's kind of the test suffers, I think, from the problem that it tests all the expected scenarios, but there's no final step to connect it to seeing what happens when you run it in real life.
Yeah, right. So
QEMU to pass the commands, or even to see if the syntax of the command line is correct. You wouldn't really see that because the test only checks expected cases in that sense.
You could say so, yes. Yeah. I mean, that's one part how one could address it, to say like, okay, there have been unit tests. Unit test is better than no tests, but a system level test here would have shown the issue. Should we have a unit test or not? Well, that's a trade-off because the system level test can be much more complicated. How to say, it can take longer time. So it would have shown the issue. Yeah, Anton.
Is there a case where we are not using the compression?
Well, take for example all the tests that don't use any kind of published QCOW images. Okay, so these are all the cases where you don't care. That's being like SP90 tests, PowerPC tests, bare metal tests. All they don't care. The installation test, which just conducts an installation based on the ISO, you don't care about compressing QCOW images because you're never ever handling QCOW images outside of the worker, right? You just dynamically create a QCOW image on the worker.
But whenever we do a QCOW, like whenever
Yeah.
it is a compressed QCOW.
Yeah. Well, you might want to ask, why do we even have the opportunity
That's my
to
point.
disable, right?
That's where I'm going.
Honestly, I don't know. I assume at some point there was a certain use case where we would need that, and maybe as often for feature switches like that, it could be that this use case is not given anymore. Let's assume there could have been a bug in in QEMU for a certain product version, maybe for a certain architecture where compression cannot should not be used, and then yeah, you can disable that. Right.
So question related to Anton's point. Should we actually just try this? I mean, if maybe at one point compression was just a new thing and now we probably want it everywhere. Let's try and see that we always use it.
We do always use it by default anyway. That's the point. It's only like allowing to disable it. And I would say
like I'm kind of wondering, are there cases where maybe we still don't compress and we just forgot about it? Would we know if we do that?
Yeah. Yeah, maybe you don't. And that's the point of this. Okay, actually I'm just shortly looking up in history of Auth Audience, and I see that I included the flag to enable compression by default in 2017. So actually in before, it wasn't compressed at all. And compression was included by Ludwig Nussel in 2015 as an optional compression of uploaded images. Yeah. So I would say from the beginning, Auth Audience was handling no compression. And then Ludwig included optional compression because at the time he had a certain use case in mind, or maybe it was a new feature at the time in QEMU, maybe not that stable. I said like, okay, let's try it out. Let's introduce it. So yeah, that could be a case of a feature switch where by now I would say we don't even allow to disable compression to reduce the complexity and reduce the risk. Okay. But now in that area, we already let me come to the things which we identified for improvements. And Joaquin, your question regarding raw, yeah. So for the local tests, when you run tests, you still have the possibility to there we don't use the compression. As far as I know, the compression then only applies when we finally generate from a local file into the file that we want to upload. So it's mainly meant for transferring and archiving purposes. There, I think it makes sense. The interesting thing is that we have relied on that feature so much over the years that effectively the system doesn't run properly anymore when we don't have that feature. But I guess that's just natural. Right. So what we did afterwards, after we fixed the issue, knowing being pointed to the issue, to the diagnosis, then it was easy to fix it. But what did we do? I wanted to conduct a 5 why analysis within the team to understand how did we come to that and what can we do as improvements. So we have done that, and we have asked these 5 questions, one after another, and for each we try to understand how we did come to that and what can we do as improvements. And you can see that one improvement is already in a separate subtask, and the others are basically all individual ideas that we can still turn into individual work items for us to work on. So why did we not prevent the merge of the pull request, right? Well, we did have unit tests, so that was fine. But we identified that we could still increase the code coverage in auth-inst, especially in this OpenQA QEMU module. And when I mean code coverage, then I don't just mean unit tests, but what Chris mentioned also, like on a system level test, testing the different features. These code parts, they are used as part of what we call a full stack test in auth-inst. But I mean, for this special case, why the full stack test didn't catch that? Well, because the full stack test puts an ISO, conducts like bare minimum what you would call an OpenQA test based on that ISO, but it doesn't check anything about a published QCOW. We do have a test for published QCOW files, but not to the full extent. So yeah, we want to add a specific test checking that QCOW images are compressed. I mean, that's kind of an obvious suggestion, but of course the next time we would have a problem somewhere else. So it's helpful, but we need to consider points that go beyond the scope of just that one feature. So potentially extends the end-to-end test. For example, we have the OpenQA and OpenQA test, where we could also use published images and sanity check them, because maybe sometimes there are problems with like the integrity of the generated image could not be ensured in some tests. And the problem is like, is it incorrectly generated? Is it incorrectly transported? Or is it maybe incorrectly loaded and used on a new test? We should use Perl signatures everywhere. That's the only thing where we have one specific ticket. And this is one which I would also like to show you in a bit more example. It's one that I picked up myself because I think as a product owner, I can work on that as a low priority task. Let's say a secondary task in the background, while the rest of the team focus on the more critical issues in the meantime. So yeah, right now we have 2 subtasks. One is to use Perl signatures in auth-inst and one in OpenQA. If you don't know signatures, let me show you an example. And I will show you this as an example because it shows already, if GitHub would work right now, then I would be able to show you that. And let me show you a second. I will export patch. And show you here. So Perl signatures can be a very simple change. Take, for example, a function sub init, where normally you would do perimeter parsing like this. So as the first line within the function, you do an array assignment of that special @ underscore parameter into a list of parameters, and here we just have one parameter, which is $self is a scalar. And instead, with signatures, what you can do is directly into the function declaration itself, put the signature. And this saves some white space. It can help to formalize it and make it look more consistent, but also it has implicit perimeter checking, meaning that if init would have been called with 1, 2, 3, or 0 perimeters, the function would not have failed immediately on call. If this one is called with any other number of perimeters than the one perimeter, which is required here, then Perl would fail immediately. So this might have helped already in the case which we have discussed in before to say, well, you try to call a function with one perimeter which isn't used, which isn't declared, or maybe the other way around. You're calling a function and it needs a perimeter and you don't define that, then running that would fail immediately. And yeah, so I'm slowly introducing that. Here you can see that in examples where I'm introducing that in the example test code within auth-order-inst, and in other commits I have been introducing this in other parts of auth-order-inst. Then afterwards I will move to OpenGA. If you like, then that could also be introduced in the test distributions themselves. Okay, any questions, notes regarding Perl signatures here?
I guess I could ask the mean question of is this the holy grail, or is this something that it absolutely won't help us with? Do we know?
It's providing more benefits than I thought already, because I already found 3 other subtle bugs in our code by introducing the Perl signatures. So introducing the Perl signatures is not that trivial. You know, I can do a simple set expression, some cool regex to replace all occurrences. Then I run the tests, and then I see a weirdly high number of tests failing because of some subtleties where it's like, okay, so we actually don't pass that perimeter anywhere, or we do pass it and we assume that it would be there, but it isn't. So yeah, that actually fixes some bugs. For example, I fixed the time step. It's not the holy grail, fixes everything, but it kind of makes sense to do that. I would say it's a good modern approach. So there was one hand raised. Yeah, Anton.
I thought that the best practice in our code was to use hashes for named parameters. So on the one hand, this would work because it will pass only the hash.
Yeah.
But the hash hides the number of parameters. So the function just sees the references. Oh, I have 1 references. I don't know how many hash elements are in this reference, or even if they are used. So
yeah.
So I don't know whether this has any.
Right. So you're right. If you're just passing like self and then hash args, right? Then we would not immediately identify if we miss to pass something, because that hash argument is also a slurpy parameter, meaning that you can pass as many elements as you like there, starting from 0, and you would need to check within the function itself what you need. But I think that's fine, because in that case I see that it's often people that introduce that. Speaking for myself here, I'm aware of what parameters I consider as required or not. In the other cases where I don't use this Slurpee parameters, then I would have assumed the parameters are correctly passed or something. But, you know, the Perl signatures would just make that a really consistent check to check for the real disturbing surprises here. Yeah. And especially also, let's assume you specify that you want to have a hash perimeter, but instead you pass a single scalar, then you would still get an error message telling you that it's not an even-sized list which you pass. Like, you know, you pass a single value, but instead you want to have a hash, meaning you need at least one key and one value. Make sense?
Sort of. Now have more questions, but they're more about Perl. So let's continue and I'll solve them on my own.
Right, okay, cool. Okay, so the second question was then after like the initial, so we identified that commit, we identified the pull request and we merged it, we didn't immediately see the problem. So yeah, Yanis, is that something we need to apply to the test modules too? I said afterwards, yeah, we can think about doing that. I suggest to do that. We can slowly adopt it over time. And maybe after we are finished with auth audience and OpenQA, we might propose like a mass change in the test distribution and see how far that goes. So second question was, why could we not link problems to the code change immediately after deployment? So we do have a regular automatic deployment for O3, it's daily. For OSD, currently every second day. Well, we identified that what we should do is to better link problems immediately to monitor the mean values of asset sizes, like the asset sizes themselves, because they grew like by factor 8 and nobody realized that quickly. But yeah, that's what we can do. We should also monitor the mean value of job completion times, because that was like a second factor which was observed but could not be linked immediately to the problem. And I think that's what we should do. We already monitor how long does it take for jobs to be picked up, like how long are they staying in the schedule, but we don't monitor how long it takes for jobs to complete. Why don't we do that? Well, you know, how long it takes for them to be scheduled is more under our control as, you know, the maintainers of the infrastructure than how long it takes for jobs to complete. If any of you change the test to run longer because you run more demanding tests which just take longer, then well, that's your choice and it's a valid choice. We shouldn't be alerted by that, right? But we should still maybe we can still gather something from overall there was a suspicious spike in the mean value of the job completion times which changed. And we were mentioning that, of course, not only because we want to find the same regression again, it's unlikely that we will have a problem soon in the same area, but rather similar other related problems that could also be found by that monitoring approach. I also think that we should deploy synchronously after every merge pull request so that we can make alerts more stricter and be more likely to link alerts to the smaller deployed change. Meaning right now when we only deploy every second day, well, that includes the changes of 2 days. So it might not be much, but it's also a bit harder to say immediately afterwards, like, oops, now something happened immediately, because it takes some time. And if we could deploy more often, then we can make alerts more stricter and make them more time bound and say immediately afterwards, if some parameters change, then we know and we can link it to the specific deployed changes. Okay, any additions to that, to point number 2? Comments you'd like to make? Nope. Okay, then why did we not link the IO alerts to the deployed change? You know, this thingy what you showed here. Well, as often we were a bit distracted by multiple network problems, which were there at the same time or at a similar time. So we knew already that there was some load due to crashing workers. It might have been some days in before, and then actually everything was fine for 1 or 2 days, and then the new incident happened, and we didn't realize that there was the smooth period in between. But to the people, it felt like we are still impacted by network problems. Yeah. So also there, the idea is that deploying more often should help, so that we can reduce this time window where we are unsure if we are still impacted by old problems or by new problems already. There are already longer existing plans to have a better network performance monitoring. So something like the bandwidth between the worker and the central OpenK instance, so that we can say, yeah, we can still upload and download with the expected speed, or maybe there's a change in that. And if not, if we have any other issues like this one, let's assume the QCOW images rise in size by factor 8, but the network bandwidth is still the same, then we say like, well, we can't blame the network because it's doing, providing the same performance as in before. We're just transporting 8 times more data. So why is that, right? Okay, and then also we came up with the idea to have a test OpenQA job that we use as a reference. So for example, something like the OpenQA and OpenQA tests, which are running in OpenQA, or maybe the OS Audience full stack test, but we check their runtime within our live infrastructure. So not just have a test within the GitHub repository, and well, we do have the OpenQA and OpenQA tests on OpenQA OpenSUSE.org, but we should have some kind of smoke test, some reference OpenQA test itself in the infrastructure that just we maintain and nobody else touches or changes. And whenever that fails, then we are pretty sure that, well, it's something that we should have something in our responsibility. Does that make sense? Number 4, why could we not link multiple user reports to the alerts, which we mentioned above? So there were user reports, and what I mean by that is that you guys, you write a question in chat like, hey, I have this job failing, it looks a bit weird, could someone take a look? Or, hey, could it be that uploading time increased unexpectedly? Or when you ask, was there some change in the infrastructure lately? And let me tell you, I really do appreciate such open questions. I appreciate that you're not just, breaking your head in your own room privately, trying to wrap your head around problems and figure out what's wrong, but really bring it out in any kind of communication and say, maybe there's a problem which has an easy explanation if we just find the right people to ask. So yeah, I really encourage all of you, use that, ask us in chat rooms where we are, like, in Matrix chat in the OpenQA room, Libera chat in the OpenSUSE Factory RSC room, in SUSE engineering testing channel. So bring up weird problems there. Yeah. So that the combination of all multiple user reports, eventually it helps. Yeah. Before there were multiple user reports which we could not link to the report. So, we needed some more weird questions by you to really come to the suspicion that something might be wrong there in code. Yeah, Janis, go on.
One question. So the only indication of the problem was visible only through the monitoring, the dashboard? This is one question I had from the beginning. Or you could find something in some logs or something else.
So there was this graph, which was one graph. There had been other alerts that had been failing at that time. For example, about the number of jobs that had been in the schedule queue, and the job age, how long it takes until jobs are picked up. That one also alerted. Why? Because tests took much longer to finish. Therefore, the other tests were blocked in the schedule for longer. So this was another alert. There were more alerts. I don't know who's here from ToolSim right now. If you remember what more alerts had been there at the time. Yep. I think there were other alerts, not at all exactly at the same time, but over the course of 1 month, of course, there had been. Oh yeah, for example, the used space for assets. That one also hit the threshold where we do call auto cleanup, but still we hit the threshold where the cleanup couldn't catch up fast enough. Yeah, and linked to that. User reports where some of you guys were asking, like, not only the examples which I shared before, but also examples like, hey, we had this build yesterday and today already all the assets were deleted. Why is that? Is the asset cleanup more aggressive nowadays? Now in hindsight, I can say, well, it needed to clean up assets earlier because every asset was 8 times bigger, right? Does that answer your question?
Kinda, yeah.
Okay. So yeah, the users reports did not tell us more than what we should have seen from monitoring data. We had an according monitoring graph for all the examples which I told, more or less had told you what I shared in before, but it confirmed the presence of issues which we should have linked. So for this, it's good to have tickets. And I mean, when we have an alert, even if the alert turns to okay again, we have a process within our team to say we still need to have a ticket. Yeah. So we don't want to have any alert where we just say, yeah, I turned okay again, let's ignore it. We really want to have some follow-up. And the same is for any other side. If there's some weird, not identified problem, let's say from the user side, if you have some report, maybe not a single job, but maybe an observation which covers more, it's good to have a ticket, which is, maybe it's lying around for some time, but in the end we could say like, wasn't there a ticket already for this? We had an alert, maybe it's linked, can take some time, but we would be able to make that link. So we also identified one action, which is we want to look up if the alerts level for assets have been bumped to very high number for good reason, lower if possible. And yes, we did bump the alert levels for this alert after we assumed like, okay, disk IO times have increased. We think everything is okay. So we changed the alerting to not to be a bit more conservative and don't alert as soon. By now we have reverted that because we have understood that the alert was legitimate at the time. So any more additions to point number 4, why we could not link multiple user reports to the alerts? No? Okay. So why did we not look into the IO alerts in more detail? And yeah, we had this alert, which I showed you, and it triggered, but it turned okay soon after. And as I mentioned already, our wiki already explains that we need to take alerts seriously. So regardless if it's okay or not, we need to have, we need to come up with, okay, I've written it down here. We need an accepted hypothesis when we want to change alert. So just, I don't see it anymore, maybe it's fine, is not good enough as a reason. We really want to maybe discuss in a team, in a bigger group, and say, what could have likely really been the reason why we had that alert which turned to okay again. Right. So yeah, so these were all the 5 points which we identified as a follow-up, and now we will see how we can progress with that. We already did some of the changes. Maybe some of the changes we will effectively, to be honest, we might never do. Some other changes we will follow up already. So, any more thoughts on that? Maybe I can get some feedback from you. How did you like this presentation of our learns about this feature? Is it helpful? Is it good? Should we repeat it the next time we have an incident, if ever?
I like it.
Okay.
Sure. It's fast.
Good. Last job.
Yeah, no, it was kind of interesting to see how you guys work and how reactions on incidents have been. Very nice.
Right. In any of your teams, do you also conduct analysis, something like that? Or other approaches to handle similar cases?
We're drowning under that. We don't do that.
For sure not as thoroughly as this one, but also we don't maintain infrastructure as big as OSC.
Well, we are not the guys releasing critical regressions. You are, right?
You mean fixes, right? Not regressions.
Yeah. Okay. Cool. So, would you like to see something like that again in case we ever have an incident again?
Yes.
Okay. Cool. So, yeah, thanks for that. That concludes the topic for today. For the next workshop, we don't have a topic defined, and also the topic for the current one wasn't set up yet. I'm thinking about for the next week to discuss one particular feature which we have in preparation, which is called force result, where one can forcefully overwrite the result of OpenGate tests with comments, and we could discuss what workflows we could set up around this feature.
That sounds scary.
Yeah, it can be scary, I guess so. Yeah, that's what I would like to discuss. Okay, then thank you all, and see you next time.